Hello everyone and welcome to the Engineer Construction Lecture Hub. Today we are going to consider a very important topic as regards to design of our slabs. But before I proceed, please do well to like this video, share, comment. If this is the first time you're coming across my video, do well to follow me for more useful updates. Alright, as you do that, that will also encourage me to do more. Alright, so let us go. Today I will talk about boundary conditions. Boundary conditions in slabs. Boundary conditions in slab. Now, when we talk about boundary conditions, we are looking at how these slabs are hinged. Okay, because before you start up your design, okay, you must analyze the architectural drawing. Okay, you identify the various panels. You do what we call paneling. Okay, now you have to split these slabs into panels. All right, now another thing you need to do is to understand their peculiarities. Okay, by knowing the type of the type of slab they are in terms of their spanning, if it's a one-way spanning slab or a two-way spanning slab. So you identify that by the LY-LX ratio. Okay, when you do that, if it is less than 1, if it's less than 2, it means that by the time you divide the length of that panel by the width of that panel, if what you have is less than 2, it means that that is a two-way spanning slab. But if it is 2 and above, it means that it is a one-way spanning slab. So, but in most cases in our buildings, we discover that predominantly the panels we have, they are two-way spanning slab. So, but you must first and foremost use this ratio to determine, their conditions, okay, before you can now proceed to the next stage. So, having identified these various panels based on their LY-LX ratio, the next thing you have to understand is their boundary condition. Okay, now for example, let's say we have a building in this form. Okay, we have a building in this form. All right, now let's say we have another this way. Okay, now for example, all of these are two-way spanning slab. Okay, let's assume they are all two-way spanning slab based on their LY-LX axis. And I said when you have this symbol in your slab, it's an indication that it is a two-way spanning slab. Okay, it's a two-way spanning slab, so you take note of it. So we assume that these 4 panels, okay, is a two-way spanning slab all through. Panel 1, 2, 3, 4. Okay, they are all two-way spanning slab. All right. Now, for it to be two-way spanning slab, it means that your LY-LX axis is less than 2. Okay, once it's less than 2, such a panel is a two-way spanning slab. So, for example, this is a slab. Okay, now we have we have allocated them into panels. All right. The other thing we want to look at now is the boundary condition. We know that all of these panels are hinged to beams. Okay, so we must ascertain their true boundary condition to enable us extract the moment, okay, from our coefficient, the moment value from our coefficient table, so we can be able to determine the moment generated within that panel, so we can now design for the reinforcement. So for example, we have what we refer to as continuous edge. Okay, we can have this as a continuous edge. Okay, is a continuous, this is a symbol for a continuous edge. So that is the boundary condition. Now in your coefficient table, we have different boundaries in terms of their continuous edges. Okay, we have situation where we have free ends. Okay, we have free ends, we have continuous edge at both ends. There are some cases we have in this form. Okay, we have free edge. All right, now what this means is that these both edge are continuous edge. Okay, why these both ends are free. All right, then there are some cases where we have at the shorter side continuous. Okay, then there are some, all right, there are some where we have it in, okay, there are some other conditions, boundary condition, but let me use this as an example. All right, for us to be able to obtain our moment values, okay, for positive and negative moments, okay, from the coefficient table, we must understand the boundary conditions of our panels, slabs, okay, the slab panels. So in this case, now when you have a slab in this form, we have panel 1, panel 2, panel 3, panel 4. You have to look at their boundary conditions. So if you look at panel 1, this panel 1 now satisfies this criteria. It means that it is hinged at this, it is continuous at this edge, and it is free at this other edge. Okay, now if you look at panel 2 satisfied. Okay, there are conditions also. We have hinge at this point, we have hinge at this point, that is continuous at this point, free at this point. Okay, so you see that panel 2 satisfies this condition. Okay, it means that partly of this, okay, let's assume, okay, this extends to this point. Okay, it means that panel 2 satisfies this boundary condition. All right, now panel 3, let's say panel 3 also satisfies this condition because it is continuous at this and free. Let's say okay, let's say panel 4 is hinged at this point. Okay, is hinged at this point. This is panel 4. So you can see that panel 3 satisfies this condition. It is hinged at this point and it is free. It is continuous at this edge and it's free at this edge. Okay, then if you look at this case now, this one now satisfies this. All right, it satisfies this because, sorry, it satisfies this C. Panel 4 satisfies this. Okay, so it means that this edge are free while it is continuous at this edge. So this is how we are expected to get our boundary condition to enable us extract our coefficient value from the table. Okay, I'm going to stop here at this point. All right, please do well to like this video, share, comment, and follow my page for more useful updates. Thank you very much and have a wonderful day. Thank you.